Simplifying the rational expressions. So up to now, we briefly discussed about rational function and their graphs. Now we want to talk about how to simplifying rational expressions. In order to do this, we need to understand few property first. What is the x to the m over x to the n? So you all know that this is x to the m minus n is from intermediate algebra, the elementary algebra course. So now I'm going to develop a little more here. What if m is bigger than n and then m is less than n? To make you understand better, I'm going to give you some example. So x to the maybe 9th over x to the 5. Then technically this means 9x's over the 5x's. Because it is division, you can cancel them out. So leftover will be 4. So simply applying this property then becomes x to the 9 minus 5, so x to the 4th power. That should be the answer. Okay. What about this case? X to the 5 over x to the 9. As you see, I flipped this numerator and the denominator. Then this means we can rewrite there are 5 x's on top here and the 9 x's on denominator. So now you simplify that. Then it become 1 over 1, 2, 3, 4 become x fourth here. So if you apply this property one more time, then you can say this is the x to the 5 minus 9 equal to x to the negative 4, so become 1 over x fourth. But can we develop a little bit easily, kind of shortcut? Then now you can say that if m is bigger than n, like this case, you can still generate so x to the m over x to the n, it become x to the m minus n. However, the denominator degree is bigger than numerator one, then we can develop this property x to the m over x to the n equal to 1 over x to the n minus m. So like here. So if we apply this property for this equation, then because denominator degree is higher than numerator, so you can make 1 over x to the 9 minus 5 and equal to 1 over x fourth. Yeah, of course you can always apply only this property, but sometimes we better make this kind of shortcut so that we can process the simplifying rational expression a little bit quicker and easily too. Okay. Second requirement is factoring. Because of many different cases, it is not given as a monomial, like one term, it became like polynomial terms, like two term like x plus 2 over x squared minus 4, something like that. So like this case, you cannot cancel like this. No way, you cannot cancel that way. Okay. Then now you need to make it each term as a monomial. So far they're all binomials, right? So you need to make a monomial. which means you are putting into the parentheses and then make a multiplying form here. Okay? So based on these two fundamental factors, now we can make some example and then try to reduce the rational expression. So now this question here, 72 x fifth and y cubed over 27 x y 7th power. Okay, how many different factors do you see? I see total 6, and then these two are number, these two are x, those two are y. So I'm gonna simplify same character factor each other. So 72 over 27 x fifth over x y cubed over y 7. So in this case, you're still using find common factor and then start reducing it. So what is the common factor between 72 and 27? It can be any factor. So I'm gonna write here. So you can apply 2, 5, 3, 7, and then write down 72 and 27 here. Yeah, you can apply one of this number. Yeah, I can see you can apply 3. So 3, and then 2, 4, and 9. You can do 3 one more time. So 8 and 3. Okay. So we cannot do any more. So that's this one. So 8 over 3. Now this case, x5, no exponent means 1. Which one is greater? Yes, this is greater, right? So become x to the 5 minus 1. Now this one, which one is greater? Yes, this is greater. So 1 over y to the 7 minus 3. So becomes 8x fourth over 3y fourth. That will be the answer. Okay, you cannot simplify two exponents because there are two different base values, so you cannot do that. So ax fourth over 3y fourth should be the answer. Now, second question. So 3y minus 12 over 2y squared minus 32. So as I told you before, this case you cannot just making to this term and then another term and then you can simplify. There's no way. You need to factoring first because they are not monomial like this case. You know, this problem case, everything is multiplying each other, right? So monomial over monomial, so you could do so. But now this one is not because they're binomial over binomial. So you must use factoring. So I'm gonna bring down 3y minus 12 first. So what's the common factor? That 3. Then become y minus 4, right? So top become 3 times y minus 4. Okay, now this one. So 2y squared minus 32. Okay, common factor is 2. So y squared minus 16. So far it becomes 2y squared minus 16. But you know that 16 means 4 squared. So this means 3y minus 4 over 2y minus 4 times y plus 4. As you see, this cancelled out. Therefore, the answer becomes 3 over 2y plus 4. Okay? So let's do just one more questions. So what about this? So k squared plus ak minus 9 over k squared minus 5k plus 4. So the numerator factor and denominator both are trinomial, so you have to factor in them as well. If you do it, then you have k plus 9 and k minus 1. This will be k minus 4 and k minus 1. So now this cancelled out. So answer becomes k plus 9 over k minus 4. Okay?